This meeting is being recorded.
Okay, so we're back with the second part of the vector lecture. So in the second part, we're going to look at scalar product, or also known as dot product. Okay, so the scalar product or dot product of two vectors A and B is denoted by A dot B, and it is defined as A multiplied, the modulus of A multiplied by the modulus of B multiplied by the cos of the theta, where theta is the angle between two vectors A and B. So let's say kita ada, this is vector A, okay, and this is vector B. Okay, so theta would be the angle in between these two vectors. So rule number one is that if there are two vectors A and B and they are parallel, then the angle between them is either 100, is either 0 or 180. So let's say kita ada this vector A and then somewhere here vector B. Kalau kita take vector A and vector B, put it together, it is either it's a full 180 or it is just 0. There are no angles in between them. Okay, so next rule, so angle between A and B is either 0 ataupun 180, and cos 0 is equals to 1, and cos 180 is also cos 0, so it is equals to 1 as well. So therefore, the dot product of A and B just becomes the magnitude of A multiplied by the magnitude of B. For rule number 2, for unlike parallel vectors, the vectors are parallel but in the opposite direction. Okay, therefore you end up with an angle of 180 degrees. Okay, so again, of course, 180 is also equals to 1. Okay, sama juga lah. So therefore, the dot product of A and B, A dot B becomes the magnitude of A multiplied by the magnitude of B. Oh, don't forget your negative sign there. Okay. Right, if two vectors A and B are perpendicular, okay, kalau perpendicular tu maksud dia, then there is an angle in between it, and it is 90 degrees. So cos 90 is equals to 0. So magnitude of A multiplied by magnitude of B multiplied by 0 just leaves you with 0. So there are no dot products there. Okay, so the algebraic properties of the scalar product for any vector A, B, and C and M is a constant. When it is a dot product of the exact same vector, then it will just be the magnitude square. Dot product does not matter whether it is on the left or on the right, sama sahaja. Okay, this is crucial to highlight is because sometimes you see vector as a matrix, and for matrix, kalau matrix A darab matrix B, sorry, it does not equal to matrix B multiplied by matrix A. But this is only for matrix. But when it comes to vector, it is equal. Okay. Now, if you have an addition of vector B plus C, you can actually multiply, dot product to the vector to each vector baru tambah. Okay. And then last kali, if you are looking for the dot product of 3 different vectors, then it would just equal to the multiplication of each magnitude. Okay. And then if you have a constant A, then it would mean that the constant can only be multiplied to one of the vectors, not both. Okay, only one of it. So M darab A, baru kita dot product dengan B, ataupun M darab dengan vector B, baru kita dot product dengan A pun boleh. Okay, and then A dot B, the dot product of A and B is equals to the multiplication of its magnitude, even only if they are parallel. That was rule number 2. And then if it is the negative, if it is in the negative direction or in the opposite direction, sorry, ni dia terlari sikit. Okay, therefore it is the negative of the multiplication of the magnitude. Right, and then A dot B is equals to 0. We're looking at number 7 here, if and only if it is perpendicular. Dia bersudut tepat. Okay, then lastly, if A, if the vector of A is equals to xyz, and also B, and therefore the dot product would equal to the x multiplied by the x's, the y multiplied with the y's, and the z multiplied with the z. Tambah semua tu lah. For unit vectors I, j, and k, we have I dot I is equals to j dot j equals to k dot k, and it must equal to 1. Okay, let's look at this example. We're looking for the dot product of these two vectors, 2i minus j, dot product with 3i plus 4k. So we're just going to take the coefficient of I multiplied with each other, the coefficient of j, which is -1, but there are no k in the second vector, so we multiply it with 0, and then there's no k in the first vector, so it's 0. It's 4 here, so multiplied by 4, which is also 0. Therefore, you are only left with 6. Show that the vectors A and B are perpendicular. Okay, so ingat tadi rules, kalau vector A and B are perpendicular, 90 degrees, okay? Therefore, leaving you with cos theta equals to 0. Therefore, the dot product also must equal to 0. Okay, so we can show that by taking the coefficient ni, multiply macam tadi, and show that it is equal to 0. Therefore, both vectors are perpendicular.
This meeting is being recorded.
Okay, so next example, the position vectors for points A, B, and C are A, so on and so forth, okay, and C pula dia tiba-tiba ada alpha. But we can look for alpha if we say OC is perpendicular to BA. So this is a bit tricky because it starts with vector of A, B, and C. So therefore, you have to start by looking for its position vector. Okay, so OC is perpendicular to BA, and therefore, the dot product must equal to 0. Okay, that product must equal to 0. So let's try and show that. So OC is alpha, 5 minus alpha minus 9. And then BA pula, kita kena cari. We've got A, we've got B. So we can look for OA and we can look for OB. Therefore, we can look for BA. Okay. This was in the first part of the lecture. You should look that up if you still don't know how to look for vector of BA. Okay. So once we obtain the vector of BA, we dot product these two vectors and we must get 0. So to obtain 0, we're going to multiply alpha darab -2, dapat -2 alpha. 5 minus alpha multiplied by 7. And then alpha minus 9 multiplied by -9 equals to 0. With algebra, you should be able to obtain that alpha is equals to 6.7. Okay, last example before we go into the third part of the lecture. K is the point 1. K is the point 1, -7, 2. L is the point -6, 6, and 8. And M is 2, 5, and 1. Find the angle between K, L, and M. Okay, so like I said, the best thing to do is to sketch your points lah, your vector points. Okay, I know, I get that it's not easy because you don't know where 1, -7, and 2 is. Okay, tapi what you can do is you just agak-agak. Okay, whether K is on the left of M or K is on the right of M, that one, nobody will really know unless you're a computer. Okay, so it's okay if you get it wrong. Tapi yang penting you can visualize how it might look. Okay, just with that visualization is already more than enough. Okay, so we're looking for the angle between K, L, and M. Okay, so that means this is the angle that we are looking for, KLM, right? So to look for the angle between KLM, we should know the vector of LK. Okay, so since we know the position vectors or the points of K and L, kita boleh cari OK itu apa, OL itu apa. So from here, we can get LK. Okay.
This meeting is being recorded.
Okay, so once we've gotten the vector of LK, now we have to look for the vector of LM. Okay, so sama juga macam tadi, kita tahu, we can look for OL, we can look for OM. So LM would be LM would be L to O baru O to M lah. Okay, so it's the same thing here. Okay, so we can get the vector of LM. Now we can start by looking for the dot product. Looking for the dot product, we get that the dot product is equals to 111. So 111 is equals to the multiplication of the magnitude. Kalau tadi kita tengok dot product is equals to magnitude of LK, magnitude of LM, baru multiply with the cos of the theta. So right now we want to know what is cos theta. So we're looking for the magnitude of LK and then the magnitude of LM. Sekejap padam dulu. Okay. So now that we know that the magnitude of LK and LM are those, and when we multiply it together with the cos theta, it should equals to 111. Okay, going back, madam tulis lah sini just in case you are wondering why are we looking for the magnitude. Okay, so this is supposed to equal to 111, right? So since we know 111, we can look for these magnitudes. Boleh bawa this whole thing turun bawah to get your cos. So that one right there is your persamaan. Therefore, the angle between KL and M is 49.31. Okay, there you go. All right, so we've entered the second part of the lecture. Look out for the next video for your third part of your lecture. Thank you very much.